In natural language processing, one of the most important factors that will determine the accuracy of any machine learning or insights that you're trying to get is the quality of data that you provide and how that data has been cleaned up. You might have heard the phrase garbage in, garbage out before. This essentially means that if you're feeding an algorithm with garbage data, so data that's not been cleaned up properly, it's not in the right format, there's loads of noise in there, then any kind of accuracy of your machine learning is going to be affected by this. There are a number of steps involved in pre-processing our text data and getting it ready for further analysis. The first step is just general cleaning, so taking our data set, getting it organized, tidying up the text, removing anything that might throw us an error, anything like that. The second step is removing noise from our data set. So if we've got aspects in our data that aren't adding any value and they're just taking up space in memory, we can remove these and we'll be left with a smaller, cleaner data set to work with. The third step is just getting that data in the right format for the machine learning algorithm we want to use. Reprocessing our text data will take it from looking something like this to this. We can see there have been a lot of transformations done here, and the lessons in this section are going to cover this step by step, taking you through each of the transformations required to get that data ready for any further analysis. With that said, let's get started now into our journey of natural language processing.
An important first step in working with text data is converting it into lowercase. Why do we do this? Well, it helps maintain consistency in our data and our outputs. When we're working with text, be that exploratory analysis or machine learning, we want to ensure words are understood and counted as the same word. Your model might treat a word with a capital letter different from the same word without this capital letter. Lowercasing just ensures conformity. It also makes it easier to continue with additional cleaning of the data, as we don't have to account for different cases. However, do remember that lowercasing can change the meaning of some text. For example, US in capital letters is understood as a country, as opposed to the word us. Let's take a look at how easy it is to convert our data to lowercase using Python's built-in lower function. So let's create our sentence that we want to convert into lowercase. For this example, we'll be using the phrase, her cat's name is Luna. We then convert this into lowercase using the built-in lower function by just running sentence.lower with empty brackets next to it. We can then print this out and see that the words with the capital letters have been correctly converted into lowercase. We can also run this over a list. So here we've got a list of 3 different sentences that we want to convert into lowercase. We'll create our lower sentence list and run x.lower for x in sentence list. We can then print this out and see that everything in our list has been converted into lowercase for us. In this lesson, we'll be using the NLTK package to remove stop words from our text. Stop words are common words in the language that don't carry much meaning. For example, the words and, of, a, and to. We remove these words because it removes a lot of complexity from the data. These words don't add much meaning to text, so by removing them, we are left with a smaller, cleaner dataset. Smaller, cleaner datasets often lead to increased accuracy in machine learning and will also speed up our processing times. The first step to remove our stop words is to import the necessary packages. So we'll be importing the NLTK package, and then from this package we'll be downloading the stop words. If you've not got these already downloaded, it may take a few minutes to install these, and then once you've got them downloaded, you can just import them. We'll then assign our stop words to a variable. We're calling ours EN stopwords because we'll be using the English stopwords. You then use stopwords, and within the brackets, specify the language of stopwords you want to use. It's then good to print these stopwords out to see which words you're going to be removing from our text. You can see here there's just a number of small words that are common in the language but don't often add a lot of meaning. So let's take a sentence we want to remove these stopwords from. In our case, we'll be using the sentence, "It was too far to go to the shop and he did not want her to walk." We then create our sentence no stopwords. We'll be using the join function here and then iterating over our sentence. We'll be going through each word using the sentence.split, which splits our sentence up into individual words, and then for each word in our sentence, if the word is not in the stopwords list, these words will be joined together. If the word is in the stopwords list, it will simply be passed over and ignored. So if we print the sentence no stopwords, we can see we are left with far, go, shop, want, walk. There may be times where you're not happy with the stopwords that are in the list and you want to remove certain words or add certain words to your stopwords list. You can do this using the remove option. So you reference your stopwords list, in our case EN stopwords, and use .remove, and then within the brackets, the word you want to remove from the stopwords list. You can also use append to add words into this stopwords list. So we've removed the words did and not and added the word go. We'll then create our sentence no stopwords custom and use the same code as before to remove our new stopwords list from the sentence and see how the results have changed. We can now print this out and see how the results have changed with the different stopwords that we've put into the list. We're left with far, shop, did not, want, walk, which to me captures the meaning of the sentence a little bit better while still removing those stopwords that aren't going to add a lot of context. Regular expressions, or regex for short, is a special syntax for searching for strings that meet a specified pattern. It's a great tool to filter and sort through text when you want to match patterns rather than hard-coded string or strings. There are loads of options for the syntax, so it's best to just jump in and get started with some examples. The first thing we'll want to do is import the RE package. Before we get started with the regex code, let's first cover the concept of raw strings. Python recognizes certain characters to have a special meaning. For example, \n in Python is used to indicate a new line. However, sometimes these codes that Python recognizes to have certain meanings appear in our strings, and we want to tell Python that a \n in our text is a literal \n, rather than meaning a new line. We can use the R character before strings to indicate to Python that our text is what is known as a raw string. Let's illustrate this by printing some text without using the raw strings indicator. So let's say we want to specify a file path. We create my folder and point this to C/desktop/notes. You can see in this text we have a \n. Now if we print this out, we can see that this \n has been taken to mean a new line. The \n has been removed, and the end of notes has been put onto the second line. Now if we simply add that lowercase r in front of our string and print it out again, we can see this has been correctly printed out, and this \n has been treated as a raw string. This is important to keep in mind when working with regular expressions, as we'll want to make sure we are using raw strings when working with special characters. Now that's covered, let's start understanding the different regex functions. The first is research. Research is a function which allows us to check if a certain pattern is in a string. It uses the logic re.search, and the first argument is the pattern to find, and the second argument is the string in which you want to find this pattern. It will return the pattern if it's found in the string, or else it will return none if the pattern is not found. Next, the re.sub function allows us to find certain text and replace it. It uses the logic re.sub, and the first argument is the pattern to find, the second argument is the replacement text, and the third argument is the string that you're looking in. Let's illustrate this. We'll start with a string. We'll take the phrase, Sarah was able to help me find the items I needed quickly. But let's say we know the spelling of Sarah is wrong and we know that it should be Sarah. We can use re.sub to replace Sarah with Sarah. So as you'll remember, the arguments that go into the re.sub function are the pattern to find, the replacement text, and the string that you want to look in. So here we're finding Sarah, we're replacing it with Sarah, and we're looking in our string. Once we print this new string out, we can see that Sarah has been switched to Sarah. Let's now go into a little bit more detail about the power of regex syntax. Let's say we have 6 different reviews from different customers about members of staff in our team. We're going to be using the power of regex syntax to pull out different reviews. So let's say we want to find only Sarah's reviews, but we also want to account for the incorrect spelling of Sarah. We'll create our empty list for Sarah's reviews. We'll then specify our pattern to find. In this case, we're going to be using Sarah with a question mark at the end. The question mark after the R means it's an optional character to match, so our search will look for both Sarah and Sarah. We then create a for loop to go through each of the reviews and pull out the ones that match our pattern. So we'll do for string in customer reviews, if research pattern to find string. So if our pattern to find is within the string, we want to append this review to Sarah's reviews. So essentially, any review with Sarah or Sarah will be appended to Sarah's reviews for us. Let's now print out Sarah's reviews. Great, we can see that the 2 correct reviews have been pulled out and put into this new list for us. Now let's try something different and look for reviews that start with the letter A. Again, we create a list for these new reviews. We'll name it A reviews. And again, we'll specify our pattern to find. So here we're using the R to indicate a raw string, and then within the string we've got the caret symbol and an A. The caret operator indicates the start of a string. So we're essentially looking for the start of a string and the letter A. Again, we create our for loop to go through our customer reviews. So for each string in our customer reviews, if the research matches the pattern to find in the string, we take this string and append it to our A reviews. Once we've printed this out, we can see that amazing work from Sadine has been correctly pulled for us. We can also, on the other hand, find reviews that end with certain letters. So let's switch this to find reviews that end with the letter Y. We use the $operator to indicate the end of a string. So here our pattern to find is Y $. We can also use syntax to find reviews that match more than one word. So here we want to find reviews that contain the words needed or wanted. We'll be using the pipe operator to do this. So we create our need-want reviews, and then our pattern to find here is R for our raw string, and then within the brackets we have the word need, the pipe operator, the word want, and then outside the brackets we have the ed. So here it's going to be looking for the word need with the ed on the end, so essentially needed, or it's going to be looking for the word want with ed on the end, so wanted. So here we can see one review it's pulled out has the word needed in it, and the second review contains the word wanted. Finally, let's look at one of the most useful and powerful things that regex is used for, and that's removing punctuation from our strings. This is a really important step for NLP, so take care to try and understand what this syntax is doing. We want to create our no punct reviews, and then our pattern to find looks like this. So we have the R indicator for our raw string, square brackets and the caret symbol indicate not, \W means word, and \S means white space. So essentially, we want to find anything that is not a word or a space. Our for loop's also going to look a little differently here. So we want to do for string in customer reviews. We create the no punct string. We'll be using the re sub function here. So we're looking for our pattern. So we're looking for anything that's not a word or a white space, so essentially the punctuation, and we're replacing it with nothing. So this is just going to remove it. And then the third argument, obviously, is just our string. And when we print this out, you can see the reviews have had their punctuation successfully removed. There are loads of options for regex, and it takes some time to get familiar with what you can do and the power of it, but it's a really useful tool for filtering through data and finding text that matches specific patterns. A fundamental step in NLP involves converting our text into smaller units through a process known as tokenization. These smaller units are known as our tokens. Word tokenization is the most common form of tokenization, where individual words in the text become a token, but tokens can also be sentences, subwords, or individual characters depending on your use case. We do this because the meaning of the overall text is better understood if we can analyze and understand the individual parts as well as the whole. It's also an important step before we vectorize our data, which we'll cover more in the next section of this course. Let's look at some examples of sentence and word tokenization using the NLTK package. So we'll start by importing the NLTK package, and then we'll download the extra pieces that we need for that. And then from nltk.tokenize, we'll import word tokenize and sent tokenize. Let's start with sentence tokenization. So we'll create sentences with 2 sentences in our string. We'll use her cat's name is Luna, and the second sentence, her dog's name is Max. We can then use sent tokenize function over this to tokenize into individual sentences. So we can see here it's been broken out into 2 separate sentences. The first, her cat's name is Luna, and the second, her dog's name is Max. Now let's try word tokenization. We'll take the sentence, her cat's name is Luna, and run the word tokenize function over this sentence. You can see how the individual words have been broken out into individual tokens. Let's try this again on a slightly longer sentence. So if we join our 2 sentences together and then run the word tokenize over this. So you can see here what I was referring to in terms of lowercasing. So our first token is the token her with a capital H, and then lower down we've got another token with a lowercase h. So if we converted this into lowercase before, they would match. So now if we were going to try and do any kind of frequencies on this, the capital her and the lowercase her might not be counted up together. So it really is important to think about that lowercase step and implement that to ensure consistency across your data. The next step in pre-processing is to standardize the text. One option for this is stemming, where words are reduced to their base form. For example, words like connecting or connected will be stemmed to the base form connect. Stemming works by removing the suffix or ending of the word, but can sometimes lead to the base form not being meaningful or a proper word. We standardize the text in this way because it will lower the number of unique words in our dataset, therefore reducing the size and complexity of our data. Removing complexity and noise from the data is an important step for preparing our data properly for machine learning. So from the NLTK package, we'll be importing the porter stemmer. We then create our stemmer and assign it to PS. We use the porter stemmer function with empty brackets to initialize the stemmer. Now let's try an example with words around the word connect. So if we take the tokens connecting, connected, connectivity, connect, and connects. So we can run through a loop and then stem each of these individual tokens and print out our results. To run the stemmer over the token, we use PS, which we referenced earlier, .stem, and within the brackets, our token. This prints this out and we can see how each of the different tokens has been stemmed to the word connect. Let's try again with some different tokens. This time we'll be using words around the word learn. So our tokens will be learned, learning, learn, learns, learner, and learners. We can take the same code from above and just swap out our connect tokens for our learn tokens. So we can see here that the first few tokens, learned, learning, learn, and learns, have been stemmed to the word learn, whereas learner and learners have been stemmed to their base word of learner. Let's do one more example with the tokens likes, better, and worse. Again, we can copy this code over and swap out our learn tokens for our likes tokens. When we print these out, you can see what I was mentioning earlier around how some words are reduced down to their base form that aren't proper words. So for example, the word worse has been stemmed to WORS. Where stemming removes the last few characters of a word, lemmatization stems the word to a more meaningful base form and ensures it does not lose its meaning. Lemmatization works more intelligently, referencing a predefined dictionary containing the context of the word and uses this when diminishing the word to its base form. This means we're often left with more meaningful words, but it does mean that we may be left with more words in our dataset. So let's try out lemmatization on our connect tokens, our learn tokens, and our likes tokens. To get started, we'll need to use nltk.download WordNet. And then from nltk.stem, we can import the WordNet lemmatizer. We can then create our lemmatizer using WordNet lemmatizer with some empty brackets next to it. Let's then run our for loops again, taking our connect tokens, printing them out, and then lemmatizing them and printing the results. So you can see here when we completed our stemming, all these connect tokens were stemmed down to the word connect, whereas here all the words have been left as they are. They've not been reduced down to one single word. This is good because it contains a lot more of the meaning of the words, but like I said, it does mean we're going to be left with a much larger data set because we're not reducing all these words down into a single token. Let's try this again with our learn tokens. And again, you can see here, the only thing that's really been reduced down is the word learners, which has been reduced to learner. Everything else has been left as it is. And finally, for our likes tokens, we can see here the difference of where the word worse has been reduced down to worse, whereas when we'd done our stemming, it was reduced down to WORS. So it does mean that a lot of the words are going to be left as meaningful words that we recognise. We can break our text down into something known as n-grams to check our pre-processing, as well as explore the contents of our data or create new features for machine learning. An n-gram is simply a sequence of neighbouring n words or tokens, where n can be any number. In order to do this, we'll import three packages: the NLTK package, the pandas package, and the matplotlib package. Now let's create some tokens for this example. These tokens haven't been fully pre-processed. We'll come on to that in our next practical lesson. So let's copy our tokens over and then print these out to have a look at what we've got. So we want to take our tokens and look at the unigrams that are present in this data. A unigram is just a term for when n equals 1. So we want to create a pandas series, so we'll use pd.series and then run nltk.ngrams. This takes two arguments. The first is the tokens and the second is the value of n. So here n equals 1. At the end of this, we'll append our value counts, so it'll look through all the unigrams and count them up for us. When we print this out, we can see the most common unigrams. So in this case, it's our most common tokens, our most common words. We can see that the word to appeared 7 times, the word of 6 times, the 4 times, etc. And you can imagine how different this would look once we finished our pre-processing and removed our stop words. We can also put these into nice charts and visuals for uses in presentations. So if we take our top 10 unigrams and then use .sort values, then .plot, followed by .bar h. We want to use a horizontal bar for this. Then we can use some arguments to make our graph a little bit nicer than the defaults. So we use the colour of light salmon, we specify the width, and we specify the size of the plot we want to produce. Of course, we also need to give this plot a title, so we'll call it the 10 most frequently occurring unigrams. So we print that out and we've got a nice chart we can use for presentations and for discussing with different stakeholders. We can then compute our bigrams. Bigrams is just a term we use when n equals 2. So we'll be looking at the common occurrences of neighbouring pairs of words. It's the same piece of code, we just change n to 2 and rename it as bigrams. So we can see here that the bigram that were appears 2 times in our data. The rest just appear 1 time, so we don't need to plot this out. Again, we can compute our trigrams. So you may guess this is just when n equals 3. So we're looking at 3 tokens that appear together. And here we are. We can see that these different trigrams only appear once, so again we don't need to plot this out, but when you're working over much bigger data or data that's been through more thorough pre-processing, this bigram and trigram analysis can give some really interesting results. Just another note on terminology, we've got the phrases unigrams, bigrams and trigrams here. When n is any more than 3, we just use the phrase n-grams to refer to this. So now we've got this done, let's jump into our practical and put everything we've learned in this section together. So now that we've covered each of the steps of text pre-processing, let's put this all together in a practical lesson, where we'll be running through each of the steps using a more realistic dataset. We'll start by importing the packages we need. So we want the NLTK package, and from nltk.tokenize, import word tokenize. From NLTK.stem, we want to import the porter stemmer and the WordNet Lemmatizer. From NLTK.corpus, import the stopwords, and we also want to import the RE package and import pandas as PD. We're now ready to load in our dataset. So we want to create our data and use pd.readcsv and read in TripAdvisor hotel reviews.csv. As you might have guessed, this dataset we're going to be working with is a set of hotel reviews. Let's use data.info to see what we have. You can see we've got 109 entries, so 109 rows, and no non-null values, which is perfect. Now let's use data.head to take a look at our data. We can see we've got two columns, one for the text review and one for the rating associated with that review. Let's also take a look at the first review in more detail. So we can see it's talking about a nice hotel, expensive parking, got a good deal, just a typical hotel review. So it looks like most of this data is in lowercase already, but let's just run our lowercase function just to make sure. We'll create our review lowercase column. We'll be taking the review column and using .str.lower. Let's run data.head to check this has worked. The next thing we're going to do is remove the stopwords from this dataset. So if you'll remember, we want to create our en stopwords and use this as stopwords and specify the English language. I've also decided I want to make sure the word not is not within the stopwords, so we can use .remove to remove the word not from our list of stopwords. Then let's create a new column, review no stopwords. Using the join function, we'll go through each word in the string, and if it's not in the stopwords, we'll use the join function to join these words together with the space in the middle. When you're pre-processing text, it is always worth making a new column for each of the steps in your pre-processing, so you can check it along the way, and if something messes up, you can just go back to the previous step in that relevant column. Let's check our working by looking at the first review we pulled earlier and seeing how it's changed. So this review is pretty clean to start with, but we can see that it has had a few words removed from it. And everything's in lowercase, so we're perfect to move forward to the next step. Let's now tackle the punctuation in our text. We want to remove the punctuation, but we notice we've got a few reviews with the star symbol instead of the word star. We want to keep this as it might add meaning to the review. We can do this with what we learned about regular expressions. So we'll start by creating our review no stopwords no punct column. You can see we're using the R to indicate a raw string, and then we're looking for the star symbol, and we're going to replace it with the word star. We'll be looking in the review no stopwords column. So this should hopefully find all the occurrences of the star symbol and replace it with the word. So if you look at line 2 here, you can see that the 4 star is in the original review, but in the column review no stopwords no punct, it's been replaced with the word star, which is exactly what we wanted. Now this has been taken care of, we can remove the rest of the punctuation. We'll just be updating the review no stopwords no punct column. If you'll remember from lesson 2.4 on regular expressions, the regex syntax we want to use to remove punctuation is square brackets, caret, \w, \s. So it's going to be looking for anything that isn't a word or isn't a white space and replacing it with nothing, essentially just removing it. Amazing, we can see that all the punctuation has been removed from our text. The next step to work through is tokenizing this text. We'll create a new column called Tokenize. So we'll take lambda x and word tokenize x and the column review, no stop words, no punct. So we're tokenizing our cleaned up data. Let's take a look at that first review again. So this is looking good now. We can see that the text has been tokenized, all the punctuation's been removed. It's a nice and clean data set for us. The next step we're going to look at is stemming. So we'll initialize our stemmer and name it PS and reference the porter stemmer function. We'll then create our stemmed column. We'll take our tokenized text from the tokenized column, apply a lambda function for the tokens. So we're going to run ps.stem on the token for each token in our tokens list. So if we now look at data.head, we can see that the words have been stemmed. Let's compare this against lemmatization. So we'll create our lemmatizer using the WordNet lemmatizer function. We'll then create our lemmatized column. And similar to the code above, we'll be applying a lambda function over the tokens using the lemmatizer.lemmatize function. Let's take a look at that first review one last time to see how it's been lemmatized. So we can see a lot of the words have retained their original word and haven't been reduced down so much as compared to when we did the stemming. So we now have a nice clean data set that's in lowercase, it hasn't got any punctuation, it's been tokenized, and we have a stemmed and lemmatized version. Let's see what this looks like now and get an idea of what's in our data by looking at the n-grams. The first step is just to create a single list of our cleaned up tokens, so removing them from the data frame. We can use the sum function here and sum our data lemmatized column with just an empty list. This will put all of our tokens into just one nice list for us. Let's now take a look at the most frequently occurring unigrams. So this is the most commonly occurring tokens in our dataset. We want to create a pandas series, so we use pd.series and then use the NLTK.ngrams function. The first argument is our token, so here we specify tokens clean, and the next argument is the value of n. Here, because we're interested in unigrams, n is 1. We then want to do the value counts of these different tokens. So if we print this out, we can see that the most common word in our data was the room hotel, followed by room, great, not, and stay. Let's swap this out for bigrams now. So we change from unigrams to bigrams, set the value of n to be 2, and print out our results. So here again you can see there's quite a few occasions where great location appeared together, space needle, Hotel Monaco, etc. So this gives you a really nice idea of what kind of topics and what kind of themes are coming up in your data without having to do any kind of difficult or time-consuming analysis. This is really interesting, like I said, to just get a really nice feel for what's in your data, what's coming up, and it's just nice to be able to check your pre-processing and just get that good understanding of your data set before moving on to any kind of advanced analysis.